Welcome to class tonight. I do hope that you all are doing well. Now, as we continue through our study of geometry, tonight we're going to be focusing on talking about circles, and specifically the distance around a circle, or what we call the circumference of the circle. Now, before we get to that, the circumference specifically, let's first cover some very important and very basic terms. So first of all, a circle. You guys hopefully you can recognize the circle when you see it. So a couple of terms we need to understand. First of all, a chord simply is, so a chord right here, simply is a segment that has two endpoints on the circle. So you see this one right here as an endpoint right there, and an endpoint right there on the circle. Next one, the radius. Now the radius is a segment from the center of the circle to the edge. So radius is very key. It runs to the center of the circle all the way to the edge. And last, diameter. Diameter is a chord, so moving back to here, a chord that passes through the center of the circle. And so once again, key, so radius and diameter both have to deal with the center of the circle, and specifically running through the center of the circle. A chord can really run anywhere it wants. Now, let's go ahead and look at example one. I actually went ahead and put it up on the screen here. Now, on example one, it says, this is on page 452. On example one, it asks for a couple different things. So I'm going to very quickly show you exactly what we're talking about. So, some examples of chords are going to be this. BC, so remember how we write this? BC with a line on top of it, that's a chord. You can say this right here is another chord, so AD, that's another chord. And then you can say really a BC, a DC, and then many of these other ones are all going to be chords. I'll just go ahead and put A, B up here as well. So those are some examples of chords on this circle, on this diagram right here. Now, radii. Now remember back for the definition, radii meant a segment with one point in the center and the other point on the end, or on the edge of the circle. So for this one, we're going to see we have the center right here, so that's going to be a radius, that's going to be a radius, that's going to be a radius, and that's going to be a radius. So all those, so I can say DP, I can say AP, I can say BP, and so on and so forth. And I can actually list several more. So those are all radii. Now last, let's talk about diameter. Now remember, diameter goes through the center that has both endpoints on the edge of the circle. So I'm looking for lines that have on the edge of the circle. So technically, that is a diameter, and that is a diameter. So let me write those real quick. So AC, and then BD. Those are diameters. Now, I do want to point out, technically, with the definition, technically AC and BD both would fit into the category of chords. So I'm going to go ahead and put AC in there just so that you guys can remember this. Technically, because both endpoints are on the edge of the circle, that is technically a chord. Even though it is also a diameter, it's still technically a chord. Now, one thing I do want you to remember, because this is one of the examples in the book, and you may have questions like this in your homework, the diameter is always twice the radius. So for example, if I know that PB, if I know that line is going to be 5 feet or whatever, I can find the diameter, I can find BD by just doubling this, so 5 times 2 is going to be 10. So the diameter is always twice the radius. That is a very important concept to remember. Now, let's go and get into the circumference. Now, just like the perimeter, the circumference means the distance around. Now, I could go into the work behind this formula, but tonight I want to focus in on the just having you memorize the formula and then being able for you to use it. Now the book, I will say the book on page 453 does an excellent job of talking about how they get the formula, and so I would definitely encourage you to check that out. We may talk about that in class tomorrow, but once again I want to focus on just using the formula on this video tonight. Now, Hopefully you remember from past experiences, past classes, that weird little sign right here, that is the Greek letter pi. Pi. That's the Greek letter pi, and that stands for 3.14. Actually, it keeps going on and on and on and on. Or we can say 22 over 7. We're actually going to use both. We're going to focus on the 3.14 tonight, and then tomorrow you actually use the 22 divided by 7, or 22 over 7 as pi for tomorrow. But we're going to focus on the formula. Now, the formula for finding the circumference, or the distance around a circle, is going to be pi times the diameter, or pi d. Now, if we have radius, so you see the first one, I see pi d, so this is if I know the diameter. If I only know the radius, I would use this formula, 2 pi r. Now, I want to point out and make sure you very clearly understand that formula means the exact same thing. You can use both of those formulas to get the exact same answer. Now, my encouragement is that this pi d is going to be a little bit easier to use. So I would encourage you to use that one first. Okay? Now let's go ahead and figure out how to use this. I do also want to emphasize they have a calculator, so I would strongly encourage you getting a calculator and using that. Go and get a calculator out now. All right, let's actually go ahead and get started with the center one right here. Let's get started with this. I'm going to pull up my calculator. All right, so I have my formula right here, C equals pi d. Now, I see that my diameter is 12, so C is going to equal pi times 12. So, I'm going to go and get my calculator back up again, and I'm just going to use 3.14, because that's the basic, so 3.14 times 12. And look at there, I have my circumference. So my circumference is going to be, oh, missed it, 37.7. Now you'll notice I actually rounded it up to the nearest tenth. And that's usually a very good idea, rounding up to the nearest tenth. Now let's go ahead and practice with this one over here, where I just know the radius. So my formula is, remember, it's almost the exact same thing, just written differently. Circumference equals 2 pi r. So in this case, my radius is going to be 5, so circumference is going to be 2 pi times 5. So all I'm going to do is, once again, get my calculator back up here. And so 2 times 3.14 equal that, and then I'm going to multiply that by 5. And there we go. The circumference of this circle is going to be, so the circumference equals 31.4. And that is how I find the circumference using just radius. Now, I have one here. I didn't put the formula because I want you to think about it a little bit. I just know the radius. That's all I know. So the only way to find the circumference of this circle is to use this formula right there. C equals 2 pi r. So C equals 2 pi r. Now my radius is 3, so it's going to be C equals 2 pi times 3. And so I'm going to get my calculator back up, put it out, 2 times 3.14, and then times 3. And look at that. I have my, so my answer, my circumference is going to be 18.8. So my circumference equals 18.8. And that is that is the basic tonight. That's how you use these formulas. All right, that is your lesson tonight. The main points I need you to remember are the terms, chord, radius, and diameter. We get those terms, and then the formula, C equals pi times d. Or circumference equals pi times the diameter, or you could also write it C equals 2 times pi times the radius. Your homework is going to be page 454, 1 through 10 even. Once again, page 454, 1 through 10 evening. Have a great night, and I will see you all in the morning.